Hey guys, how's it going? Welcome back. Just going to keep on working through our Math 30-1 trig unit. So in the textbook we use, this is the second last topic in chapter 5. So we're in trig functions. So far we've done the graphs of sine and cosine functions, and then we've done the transformations of those graphs, and that was the second topic. And now the third topic, very quick topic, is what we call the tangent function over here. All right. So sketching the graph of y equals tan x, we're going to do the same thing that we did with the sine and cosine graphs. Look in our unit circle. If we have an angle of 0 radians, well, we know that tan equals y over x, or same thing as sine over cos. Okay, so we look over here at 0. If we go sine divided by cos, sine is the y, cos is the x. 0 divided by 1 is 0. Okay, next I'm going to go to the angle pi over 4. We have root 2 over 2 divided by root 2 over 2 is 1. Okay. Now what we have over here, if we look at pi over 2, we have 1 divided by 0. Okay. Now 1 divided by 0 we can't have. That's a math rule that would be breaking there. So what we do in those situations is we draw a vertical asymptote at pi over 2. All right, sound good? Now, what I want to take is take a look at what this point over here. Now this point is going to be slightly less than the angle of pi over 2. And here's the way I'm going to describe this point. I'm going to say this guy is almost 0, comma, almost 1. Okay. Now, the idea is, in this case, if I'm taking a number very close to 1 and dividing it by a very, very small positive number that's almost equal to 0. Now, the idea of what's happening is, as this angle gets close to pi over 2, this graph is going to start approaching this asymptote, but going up to infinity forever like this. Okay. Now, so that's happening. The closer, that means the closer that this angle gets to pi over 2 over here, that means the closer that our y value gets to 1, closer that our x value is getting to 0. Okay. If I start going in the opposite direction and say now I go to negative pi over 4, which is the same thing as 7 pi over 4, we have negative root 2 over 2 divided by root 2 over 2 is negative 1. At negative pi over 2, it's negative 1 over 0. We're going to have a vertical asymptote over here. Okay, and this graph is going to be the exact same thing, except it's going to be going and approaching downwards to the asymptote there. Okay, just following this pattern around. If we had 3 pi over 4, so it's right here, we have root 2 over 2 divided by negative root 2 over 2 is negative 1. Pi is 0 divided by negative 1, 0. 5 pi over 4 is negative root 2 over 2 divided by negative root 2 over 2 is positive 1. 3 pi over 2 is negative 1 over 0, so we have an asymptote here. And the pattern repeats itself. Like this. And then over here, guys, the exact same thing. And there's what our graph of y equals tan x looks like. All right. Okay. Example 2 says state the domain in radians and degrees and the range and period of y equals tan x. Does the graph have an amplitude? All right. So looking back at this graph, x is available to equal any real number, except it's not allowed to equal wherever we have a vertical asymptote. Okay. So the way we're going to state the domain is I'm going to use set notation for this. Come on. All right, so a lot going on over here. But we're saying x not allowed to equal pi over 2 plus pi n, where n is an integer. Now, we talked about general solutions a bit in the last unit, so this is kind of like a general solution, except we're saying what x is not allowed to equal. Okay, so if we go pi over 2, the next non-permissible value, if I go add pi, I'm going to get this guy over here, which would be 3 pi over 2. If I subtract pi, I get this guy and this guy over here as well. So these ones over here is the values that we're going to be excluding for our x values along here. Okay, our range is just going to be all real numbers. Okay, all right, so there's the domain and the range of y equals tan x. Okay, what's the period? If you look at this graph over here, hopefully you see that this graph keeps cycling through, and the period goes from negative pi over 2 to pi over 2. The length of one cycle in this case is just going to be pi. So the period equals pi. Last thing, does the graph have an amplitude? So no, the graph does not have an amplitude. And the reason is because there's no max or there's no min. Since the graph goes up forever and down forever, that means there's no min or max value. So we know that there is not an amplitude. I'm going to say but the graph can be vertically stretched. So guys, in terms of the curriculum, this is really all you need to know about this topic. Okay, so you need to be able to identify what the domain and the range are of y equals tan x. You need to know that the period is just going to be pi over here. And you need to understand that there's not an amplitude because there's no max or min value, but you still can stretch it, right? So there's not a whole lot in the curriculum based on this lesson over here. Okay. What I like to do is just say, here's one example over here. So technically over here, guys, this is even outside of the curriculum because we're not supposed to do transformations of tan graphs over here, but we're going to do a quick little example for this one over here. All the following have the same period except, so over here. Now, the answer to this question, guys, is actually going to be D. Okay. Now, the reason is, okay, why I think C is a very tempting option because, like, if you see here, we have B values of 2 all the way over here. Okay, but the reason why the answer is D and not C is that for these two graphs, our period equals 2 pi over 2, which is pi. Okay, but the thing we talked about in the last example is that the period of y equals tan x is pi. It's not 2 pi the way that sine and cosine graphs are. Okay, so if we look at this graph over here, we know that for option C, our period is also going to be pi for this one, and that means that this guy over here, we have our period equals pi over 2. Okay, so for A, B, and C, the periods are all pi, but then for option D, the period's actually going to be pi over 2. So one little note I'm going to add over here. I don't know if you can hear that, but that's my big dog named Isosceles. He's just sitting down on the couch next to me. All right, so this equation over here is for sine and cosine graphs, period equals 2 pi over b. but for y equals tan of bx, the period equals pi over b. Okay, so this is kind of one key difference over here. Okay, now, I mean, if you're in my class, guys, you're going to see a question like this on a test somewhere. Okay, so we're going to give you almost the same type of thing, where the point of the question is you need to identify that based on something like this. What's the period of this type of graph? What's the period of this type of graph? What's the period of this type of graph? What's the period of this type of graph over here? And you need to be able to identify them and be able to know that this rule. For sine and cosine graphs, the period equals 2 pi over b. For tan graphs, the period is pi over b. All right, guys? Hope that makes sense, and I'll see you in the next video.